Hello everyone, welcome to all in this lecture. So in this lecture, I'm going to discuss centroid and center of gravity. Okay. So center of gravity, generally we denote by C dot G dot. So center of gravity of a body is the point through which the total weight of the body acts or concentrated. Okay. So whole weight of the body is concentrated at a certain point. So that is called center of gravity. Or we can say whole weight of the body is located at some point. So that is called center of gravity. For example, suppose this is one of the body, total weight is W, and here suppose this is a CG. So whole weight, we will assume that whole weight is acting here at this point. So this is called center of gravity. The center of gravity is the average location of the weight of an object. And for a single body, a center of gravity is fixed for a particular point. It will not change. A body is having one center of gravity for all position of the body. So for one body, center of gravity will be 1. And what is the centroid? So you will see when you will calculate center of gravity for area. So that is called centroid. So in this case, you will see centroid and center of gravity are the same. So the point at which the total area of the plane figure, like rectangular, square, triangle, quadrilateral, circle, etc., is assumed to be concentrated, is known as the centroid of the area. Centroid of the area. So in this case, you will see the centroid and the center of gravity are both the same thing. For example, rectangular center of gravity will be here. Suppose this is the length, this is the width. So it would be L by 2 from width direction, or L B by 2 from the width. Okay, so this is also called, we can call centroid, or this is also we can call center of gravity. Both are the same thing. Now we can calculate center of gravity by using the various method of moments, integration method, or graphical method. So from some geometrical consideration, we can locate center of gravity or centroid. So I've shown one figure. This is a rectangle. Their length is L, width is H. So centroid is lying at L by 2 distance from the width side and H by 2 distance from the length side. In the case of, or also we can define, or we can locate centroid when the centroid is the meeting points of the diagonal, the two diagonal. So this is the meeting point. So this is one diagonal. This is the second. This is one, or this is the second. So they are meeting at certain points. So this is also called centroid. Or also we can define, suppose a line we are drawing middle side of this, from here to middle of this to here. Opposite middle point of opposite side, sorry, like this. No. So this middle point of this side is this, middle point this side is this. Okay. Here this. So by joining the line of middle point, joining the line of middle points of opposite side, so we'll get this line. Similarly, joining the middle points of opposite side, so it will cut, it will intersect at a point G. So that is called centroid of that area. Okay. In the case of triangle, what will be the centroid? So in the case of triangle, where the all medians or where the three medians will meet at a certain point, in this figure you can see all the three medians are meeting at this point. So this point is called center of gravity. So what is the median? Here AD, BE, and CF are the medians. So median, we define a line to connect the vertex of a triangle to the middle point of opposite side. So see, this median is joining a line between the vertex, that is A, and center point, middle point of BC line, middle point of opposite side, that is D. So joining of these 2 points is called the medians. Similarly, for B, this is the vertex and this is the middle point of AC line. So by joining the B to E, so this is the median. Similarly for CF. So intersection point or meeting point of all medians in the case of triangle, that is called centroid. In the case of trapezium, the parallel side is given A and B. Parallel smaller side is A, larger side is B, and their height, perpendicular height between these parallel lines is h. So centroid at a distance from the larger side would be h by 3 into 2 into b plus 2a divided by b plus a. From the smaller side also we can write. So that will be h by 3 into a plus 2b divided by a plus b. So in this case, a plus 2b, from the larger side, b plus 2a. For the case of semicircular shape of area, so for circle, we know, suppose circle, their diameter is d. Diameter is d. So center would be here at a d by 2 distance from each points on the circle, d by 2 distance. Okay. But for semicircle shape of area, so centroid will be 4r by 3 pi distance from the diameter side. Okay, from here. Okay. And this centroid will be lie on this line because of this, according to this line, this semicircle with symmetry. Okay, if you will fold this, suppose this is suppose you have drawn this shape on this paper, and if you are folding according to this line OC, so it will be overlap. For the case of segment of a circular section, so centroid is from the O that is given in the figure, that is equal to 2 by 3 into r sine alpha by alpha. Here this alpha is in radian and here this alpha in degree. Okay, and alpha is the semi angle. You can say alpha is the semi angle. For the hemisphere, what is centroid for a sphere? Suppose this is a sphere. So this will be diameter is d. Diameter is d. So it will be d by 2 distance. Centroid will be d by 2 distance from the each point on the sphere. In the case of hemisphere, the centroid will be 3r by 8 distance from this horizontal portion. Okay, and by using the different method, we will calculate also. But for now, I'm just writing. So what is the centroid for different shape? For the right circular cone, for the right solid circular cone, right circular solid cone, the centroid will be h/4 distance from the base, This is the segment of a sphere. So for the segment of a sphere, their height is, you can see their height is h. Centroid will be from the center, that is O, 3/4 into 2r minus h whole square divided by 3r minus h. So these are the all results that you can remember. And for the line, what will be the centroid for the line? Suppose this is the length L, so centroid will be at a L/2 distance from the end. Okay. Now, in many practical cases, you can see or you can find out without calculating what will be the center of gravity. I'm showing some figure, like suppose there is some rod of length L, and you don't know the center of gravity. If the rod, their density is not changed, their cross section is not changed, same throughout the length. So center of gravity would be at the L/2 distance from the end. But suppose in other cases where the rod thickness is changing, rod cross section is changing. So how we will find out the center of gravity? So what we will do, we will lift the rod with the finger. So we'll see and we will change the place. So at one place, we'll just put the finger and we'll try to lift, then rod will be horizontal. Okay, and that will be stable. It will not goes down like this or like this. It will be stable. So once it will be stable, so that is center of gravity. Okay, how? See, this is the rod of length. This is the rod, and we are lifting by finger. So finger we have placed here. So whatever the point of contact, we are getting some support. The rod is getting some support throughout this point of contact. Okay, so the center of gravity, suppose it will be here. So it means total weight of this rod will be act on the center of gravity. So if the weight or if the center of gravity is coincide with the point of contact, it means we will not get any couple moment. We will not feel any moment. So this will be stable. Suppose center of gravity is here. I am discussing some other example. I'm taking another example. Suppose your finger is here, so you are getting support. Rod is getting support here, and center of gravity is somewhere here. So concentrated weight will act here. So it will get a moment, and it will be not stable. So it will be unstable. Okay, so you can find the center of gravity of a rod of a different material. Now, suppose you are trying to lift a hammer with one finger. So it will be stable when the center of gravity will be here. So center of gravity, the load, whatever the hammer of load will act here, and we are giving support here, so it will be stable. You've seen in the many places, like mostly in the garden, that children are playing on these types of wooden systems. So what is happening there? Suppose this length is L and this length is also L. Means their length is equal. They are sitting on the equal distance from the supports. So here this is a pinned connection. So here they are getting support, right? And their center of gravity are somewhere. Suppose they are sitting like, suppose their weight are same. Their weight are same, W and W. So by geometry, you can say center of gravity will be here. Center of gravity of this body will be here. It means total weight, the 2W, total weight of these two children is acting here. And this total center of gravity is lying on the line of reaction, on the line of support. So it means they will be in horizontal position. This rod or whatever, this wood will be in horizontal position. But once you have increased the load, like some heavy person set in this side, so what will happen? Center of gravity will shift here, and this will go down. So because of this, a couple moment will create, and this person, the heavy person, will go down. Right. Suppose this is some iron plate or wooden plate, something, and this centroid is suppose here. This is G. So if you will try to lift this shape of with a pencil or pen or with rod, so if you have put the rod at exactly at this position, so what will happen? This plate will be stable and this will be in horizontal position. Okay. So for the any plate, you can get the centroid. You can find the centroid like this by doing this experiment. You have seen that a people in this figure, you can see a people is trying to stand on this rope. So how they are doing, how he is doing, suppose this point, at this point, at this point, they are getting support from the rope. So they are getting some reaction at this point. And their weight, central gravity of this body, his body is somewhere here. Okay, so what he will do, he will try to keep his center of gravity on the line of support. So one center of gravity will be here, so it will not get any moment. So it will he can stand like this. Okay, but once center of gravity will be here, somewhere here, it will feel due to his weight, it will feel a moment, and he cannot stand on this rock. Okay, so this is the art. You can say not every person can stand. So those person who can stand, those who has done practice to keep center of gravity on the line of support or line on the line on this vertical line of this rope. Okay. In this figure, the next figure, you can see this person, suppose had the center of gravity. So this person is trying to keep his CG or G according to the line of action of support. Okay. So if he can do, if he can coincide the center of CG with the line of support, so he can be stable. You've seen in the bank of river and the sea, bank of sea areas, so people are doing like this. Suppose for this stone, center of gravity is here. For this stone, center of gravity is here. For this stone, center of gravity is here. For this stone is here. So if you will try to keep all the center of gravity of all the stones in a vertical line, so that structure that you are making, that will be stable. Okay. Many practical cases you have seen that in nowadays in shop and in home also we are doing these things. So this is the weighing machine and we are measuring mass of a material. So this length is same. This length is same, and there is a one needle. So what we do by measuring this some mass, we see that needle should be in the vertical position, and we keep some weight, some standard weight in this here. Suppose we kept 5 kg, okay, and we are placing some material here. So what we see that it will be, suppose in the middle, it means this rod will be in horizontal direction, It means whatever we are getting some weight or force, so it will be at here also. See, when the length is same and where the weight is same, so center of gravity will be lie here. Okay, so it will be horizontal at only one condition, when we place some material that weight is also 5 kg. So in that case, it will be horizontal. Suppose we kept some more material compared to this 5 kg. Suppose we place W and that is more than more than 5 kg. So what will happen? This will be heavy. So center of gravity will be shift here. Will be shift here. It will be here, and some weight will come. So this system will get a moment, and this will be go down. So you will see that horizontal direction will get changed. So rod will slightly rotate with this angle. Similarly, in the case when the W1 is less than 5 kg, so you will see in this case center of gravity is shifted here, and because of this whole weight of concentrated here, so it will get moment, anti-clockwise moment. So because of this, that rod will be rotated in opposite direction. Okay, so to keep equal amount of mass, we should keep this would be horizontal. We have seen in the construction site, these types of machines are using to lift some heavy weight. Okay, so suppose this some heavy weight, including this weight and this machine, center of gravity of this whole body is here, and point of contact is here, means reaction will come here. So see, in this case, moment will act here, and here is also one support, so it will be stable. But suppose you are increasing some weight, means that machine is trying to lift some heavy weight. So this center of gravity will shift on the left side. So once it will be goes just beyond this point of contact, somewhere here, so you will see whole weight of this body is acting here on the CG, and this will be fall down. Okay, so you have seen that on the machine it is written maximum capacity to lift a weight. It means maximum capacity decide that how much center of gravity can shift. Okay, if this machine will try to lift some heavy weight, so in this case it will be fall down. It cannot carry. Okay, so they have to, so they are designing a machine to keep some maximum amount to lift their maximum their capacity to lift the maximum amount, so that center of gravity should be lie in this range. Okay, in the case of buses, we have seen that we are placing the luggage in this compartment. Most of the luggage we are keeping in this compartment. So why we are keeping, suppose this is two wheel of bus, and this is I'm making the cross-sectional view. Okay. So by doing this, keeping all the luggage here, we are keeping center of gravity at the lower as much as possible, so that toppling will not occur, and this will be safe. Once this CG will go up, so by any toppling, like some undulation ground came, so it will become like this. And CG suppose will be here, so it will be goes down. So toppling will occur. So to avoid the toppling, we try to keep as much as lower portion of the CG, so that CG from the distance between CG and the road, it should be minimum. See, when a person is standing, so some center of gravity will come here. Okay, but by bending position, he shifted the center of gravity here. By bending position, he shifted the center of gravity some outward direction. So why he's doing, by doing this, and he's getting support from here. So by doing that, he can start the running with a faster speed. So by doing that, he can start with a faster speed. Okay, if he will stand, so he cannot start with a faster speed. To start the faster speed, to start with a faster speed, you have to be bent. So why we are bending? To keep center of gravity in outward direction, to forward direction. While the swimming, see in the first case, see this is the center of buoyancy, where the buoyancy force will act in the upward direction. Their force is denoted by FB. This is the center of gravity, so weight of his body will act downward. So see, here he will or she will get a movement. She cannot stand like this horizontal way. So what will happen? This whole body will try to go down. But in the second case, you can see he's maintaining his position in such a way that then force of buoyancy and force of gravity are acting on the same line. So by maintaining this position, the force of buoyancy and force of gravity are lying on the same line. So it will not get any movement. So he can be float like this. He can maintain a position like this. So when a good swimmer, when he get tired, so he can take rest like this. No need to give effort, and he can float by maintaining this position. In the racing car, this is the figure of a racing car. Okay, so racing car, we need to, it should be go for higher speed. Okay, so what we are doing, we keep this wheel is in a wider. Okay, and weight, and we keep CG of this body, this racing car is minimum as much as lower with the ground. So the distance between the center of gravity and with the ground, it should be minimum. So by doing this, what will happen? Very less chance to get toppling. Okay, and it will be safe for the higher speed also. Okay, suppose I'm writing here, this is the wheel of the racing car, CG somewhere here. Okay, and suppose it is rotating at this point. Okay, so it will rotate like this. Some wheel came here, some wheel came here. So this is the point of contact and center of gravity here. Okay. So you will see whole weight is acting here. So this is also safe side. The car will go down on this side, not this side. Okay. Now in some other cases, you can see the two person are sitting in this or standing in this boat. So their center of gravity is somewhere here, and their B, that is buoyancy, is acting here. So that is a stable condition. In other cases, when they move on the left right side, so they have shifted the center of gravity here. So what will happen? Their weight, suppose the total weight will act on this CG, so they will feel a movement. And that is not stable. They cannot be, this boat cannot be stable. This is unstable condition. Same concept is applying on this for the ship. So you can see here, this is the center of gravity, and this is the buoyancy force, center of buoyancy force. So see, when this center of gravity is shifted on this side, so due to this weight, a resisting moment is developed. A resisting moment is developed, and this ship will be regained and will be take its original position. It will be take its original position. But in this case, when center of gravity is here, so how center of gravity will be shifted to top? Suppose we carry some heavy load. So by keeping some heavy load, center of gravity will be goes up. So in this case, we will see when the center of gravity is shifted. So you can see a moment. So a moment will take the moment from this point. So we'll get, suppose this length is L. So we'll get a moment that is we can so call overturning moment. So W into L. And we have not any moment to resist this moment. So it can be, it will not be safe. It is unstable. So it will go down. Okay. It will go down. It will goes down like this. So for these types of so what we are doing here, so in this case also we are keeping some limiting weight that we can carry. We cannot carry a heavy weight, okay, because it should be designed for the some certain or some limited weight. For the in case of toy, see here the point of contact, here the center of gravity of this toy. So what is happening? Center of gravity is lying here, weight will act here. So this weight will coincide with the reaction. So in this case, it will be stable. When you will shift with the finger like this. So what will happen? See, center of gravity is here. So weight will act here. Point of reaction is here. So you will see by between this weight, it will be feel a moment. So by this resist, this is called the resisting moment. So by due to this resisting moment, this will go in original position. So you can see by doing this, it will not be this unstable. It will be going first position. You have seen when the road are inclined. Inclined means we have provided a super elevation. Road is not like this. Road is something like this. Okay, with an angle. And this is a car. Suppose, for example, this is the road incline. Okay, so see, so when car is going on this inclined road, so what will happen? Center of gravity, suppose this center of gravity of car, so whole weight will act here. So what will happen? It will be stable. Okay, but in this case, when car is going like this, so we can see center of gravity is shifted just left side of point of contact reaction. So by when it will happen, so this car will go down, toppling will occur. Okay, but this is the we can say stable. So we also have to see, like, by doing this, factor of safety should be inside the wheel. Or in this figure, according to this figure, it should be right side of point of contact. Center of gravity of a plane figure by method of moments. So there are different types of method: integration method, method of moments, graphical methods. So I will discuss here method of moments. So whole area, suppose this total area is A in this figure. So whole area we have to divide in number of segments, and we will divide, or we will choose a segment in such a way that each segment should be well known centroid. Like we choose segment like rectangle. For rectangle we know the centroid. For triangle we know the centroid. For circle we know the centroid, like this. So we have to divide whole area in number of segments, and for each segment, suppose this, for the first segment, that is here, centroid is here. So we can, the distance between the y-axis to the centroid, that is x1, and from the x-axis, that will be y1. For the segment 2, the distance between the y-axis to the centroid, that is x2, and from the y-axis, that is y2. Similarly for segment 3, segment 4. And then we will take the moments of all the segments throughout the y-axis or throughout the x-axis, and then we will take the moment of total area. And suppose the center of gravity, we have taken assumption the center of gravity is here of total area. So that will total x bar. I'm writing distance between the y-axis to the center of gravity of this area. Similarly, from the y-axis, that is y bar from the x-axis. Now, so what is the area here? What is the A1, A2, A3, A4, A4, A5, and so on? So this A1, A2, A3, A4 are the area of segment, area of each segment. What is the X1, X2, X3, X4 here? So this X1, X2, X3, X4 are the distance between the y-axis to the centroid. Similarly, Y1, Y2, Y3, Y4, these are the distance between the centroid to the x-axis. So now we can write moments of all segments, moments of all the segment of area from y line, or we can say y-axis. So what is the moment will come? Area into perpendicular distance. So for the segment 1, it will be, we can write A1, x1, A2, x2, A3, x3, and so. Okay. Similarly, we can suppose this is the center of gravity and this x bar, y bar is mentioned. Total area is A. So we can write moment of total area about y line, y-axis. We can write moment will be equal to total area, that is capital A into what is the distance, capital A into from the y-axis, that is x bar. See, this is the equation 1 and this is the equation 2. Both are the same thing. We are calculating moment from the y-axis of the same area. So with that we can equate these two moments. So by equating these two moments, we can write Ax into A1 x1, A2 x2, A3 x3. So from here we can write x bar is equal to A1 x1, A2 x2, A3 x3 divided by capital A, where the capital A is summation of area of all segments, A1 plus A2 plus A3 plus A4, so right. So to find out the area of composite figure, you should remember this formula. Similarly, we can calculate for y bar also. So moments of all area of segment about. Now we have to calculate the y bar. So we have to take the moment about x, about OX or x-axis we can write. So that way we can write M A1, A1, Y1, A2, Y2, and so on. Similarly, we can write moment of total area about x-axis. Can write A into y bar, and we can equate this moment because we are taking the moments of this area about the same axis, x-axis. So we can equate moment A y bar equal to A1 y1 A2 y2 A3 y3 and so on. So you can write A1 y1 A2 y2 and so on, divide by A1 plus A2 plus A3 plus A4. Right? So this is the capital area. Or we can write in terms of summation also. Same formula I'm writing in terms of summation, like x bar, we write in terms of summation I is equal to 1 to n ai into xi divided by summation of I to 1. I is equal to 1 to n and I will vary from 1 to n and this ai. Similarly, we can write for y bar also, summation of I to 1 n ai yi divided by summation of y to 1 to n and ai. Okay, so we have to divide all, we have the total area in number of segments, or number of segments we have to choose in such a way that we should know centroid of each area. Okay, now I'm going to solve one numerical problem. So the dimension is given, so the top width is mentioned, that is 120 mm. Here this is given 30 mm, and this length, this T portion, outward portion length is given 100 mm. Okay. See, due to symmetry, we can say the centroid will lie on this line. Somewhere here, I'm writing, and I'm taking the assumption this from the top, this line. This is y bar lie here. So y bar is unknown. So I'm dividing this T section in two segments. The first segment is this, and the second segment is this. So for the area, we can write segment 1. We can write A1, that is 120 into, or this is a segment 120, this is 30. So 120 into 30. Now now y1. What will be the y1? So we know for this segment, we know the centroid will be here, and this is the rectangle, so centroid will be b by 2. So 30 divided by 2 is equal to 50. So 30 divided by 2, it will be 50. Now for the segment 2, what is A2? So segment 2 is this 100, and this is 30. So 100 into 30. Now y2. So for this segment, this is also a rectangle, so centroid will be here at half of distance of this. So 100 divided by 2, it will be 50. But see, we have to calculate y2 from this line. So it will be 50 plus this length, that is 30. So it will be 80 mm. So now we have the formula. We can apply y bar a1 y1 a2 y2 divided by a1 plus a2. So we can write 120 into 30 into y1, that is 15, plus a2 100 into 30 into 80, dividing by 120 into 30 plus 100 into 30. So I've calculated, so I'm writing directly. So that will be 85.45 mm. No need to calculate x bar, because x bar in the beginning we know due to symmetry. So this is another example I'm showing. I'm going to calculate in this case. See, this shape is not symmetry. So we will calculate x bar and y bar. So I'm taking the, see, to calculate the center of gravity, we have to take the reference. So center of gravity or centroid should be, we will take with the reference of a point of a line. So that line is called axis of reference. Okay. So always we have to choose what reference that we are taking. So I'm taking this reference, for example. This is y and this is x. So suppose centroid somewhere it will be here, imagine. So this distance will be y bar, and this distance will be x bar. Let me write the dimension once. So this is the 50 mm. This total from here to here, that is 200. This total is 160. All are in mm. And this is 80 mm. 80 mm. So we can calculate. So I'm dividing, taking the section like this. This is the section 1, vertical rectangular shape. This is second section segments. Okay. So let's calculate for segment 1, x1 bar, x1 and y1. Segment 1, what is A1? 200 into 50. What is x1? See, centroid of this first section will be here, somewhere here. So we can write x1, that will be this. That will be 50 divided by 2, 25 mm. 25 mm. Now y1. So y1 would be from here. See, y1. So that will be 200 divided by 200 mm. So 200 divided by 200 mm. Now for segment 2, A2, what is the segment? So this is the, sorry. For the segment 2, so this is the reference line, that is OY, okay, and this length is here. This is 2. Okay, so the dimension is 80 and this dimension total is 160. So this will be 160 minus this length. Got here to here. So 50. So it will come 110. The centroid will be here. So this distance will be 110 divided by 2. But we have to calculate x2 from here, from the reference axis. So first calculate the area A2, that is 110 into 80. Now x2, that will be 50 plus 110 divided by 2. This will become 105. Now y2. So from this axis, this is the x-axis. So from this axis, y2 will be 80 by 2, means 40 mm. Now we can calculate x bar. I'm writing directly. So x bar will be equal to x1, a1 x1 plus a2 x2 divided by a1 plus a1 plus a2. So 200 into 50 into x1, 25 plus 110 into 80 into x2, that is 105 divided by total area. Or we can write a1 plus a2. So I've calculated, so I'm writing here x bar will come 37.252 mm. 37.52. You can calculate, you can use the calculator and just calculate this value, if you are getting this value or not. I have calculated, so I'm writing directly. Now y bar. Similarly, we can write a1 y1 plus a2 y2 divided by a1 plus a2. So 200 into 50 into y1, that is 100 plus 110 into 80 into y2, 40, and divide by 200 into 50, that is a1, 110 into 80, that is a2. So you can calculate, have calculated some writing, that is 31.914 mm. Okay, so I'm writing dimension here. So this is another example. This is one. This is 200 mm. This total length is 300 mm, and this thickness, each thickness is 50 mm. It means this will be also 50. This will be also 50. Okay, see, due to, if I'm drawing a line in between, so due to this line, centroid will be, due to symmetry, centroid will be here, somewhere here on this line. But I'm taking, suppose G, this is centroid for this area. So we have to calculate only the x bar. We have to calculate only x bar, because y bar we know it will be at a distance of 150 mm. That we know, that is y bar. Okay, so we have to calculate. So we have to divide this segment. So I'm dividing this one segment. This is second, and this is third. So third segment, what will be the height for third segment? See, total is 300. This is 50. This is 50. So it will come 300 minus 2 times 50. It will come 200. So now, for segment 1, what will be A1? 200 into 50. What will be the x1? So centroid we know. Somewhere here it will be distance of h by 2. H is 200 divided by 2. So it will come 200 divided by 2 in 100 mm. Now segment 2, A2. What will be A2? So see, total height is 300, but top 50 and top bottom 50 will be have counted in the section 1 and 2. Okay, section 2 here. So section for the A2 will be also 200 into, because segment 1 and 2 are the same. Now segment 3. For segment 3, A3, that is 200 into 50. X3 will be, see, this is the, we have to calculate X3, so the center, and the center would be, see, total width is 50, so center would be 50 by 2, 25. Now we can calculate X bar. So X bar will be X1 by A1 X1 plus A2 X2 plus A3 X3 A1 plus A2 plus A3. So we can put all this value, we can get the result 200 into 50 into 100 plus 200 into 50 into 100 plus 200 into 50 into 25 divided by 200 into 50 plus 200 into 50 plus A3 100 into 50. You can calculate, you can get some result. So I have calculated, I'm writing directly. So that would be 75 mm. Okay. Means centroid for this case will be 75 mm. These are the solutions that I have taken to make this lecture. Thank you. In the next lecture, I will discuss the integration method and I will show some more problems than interiors of problems, like in a composite figures where this circle is attached with the rectangle or triangle, one half of semicircle is attached with the rectangle. So how we can calculate the centroid in that case. Thank you.